To start off our next unit, we have to do a good review of a couple of different parts of math. One is going to be scientific notation, which is sometimes called exponential notation. Now, I know some of you already know some of this, but for the rest of the course, we're doing a lot of different calculations, and knowing how to express numbers in scientific notation and turning them into real numbers is something that you'll see a lot. So we want to make sure everyone's comfortable with that going forward. So why do we have scientific notation in the first place? When we have really big numbers and really small numbers, they're often very cumbersome to write. Lots of zeros, lots of decimal places. So it helps us write a notation that's a lot more manageable. So this is really helpful for scientists, especially chemists. If you think about things like atoms or ions or molecules, they're really small. So you can have a lot of them in a particular amount of a substance. So let's take a look at what scientific notation is. So this is to express a number. We use a coefficient, which remember is just a number, and it's going to be multiplied by 10, which we call a base 10, and it's raised to a power. And when we say raised to a power, it just means it has an exponent on it. The exponent's really important because it's going to tell you how many places the decimal place has been moved and in which direction it has been moved, to the left or to the right, to have a larger or smaller number. So let's take a look at a couple of examples and put them into scientific notation. So what if you have a number greater than 1? So what we're going to do, we look for where the decimal place would be located. So it's not shown in that number, but if we were to put it in, it would be right there. Then what we want to do is move the decimal place over 1, 2, 3 spots, and we're going to stop when we get just before that very last number there. We don't want to go past it, we want to stop just before that very last number. Then what we're going to do, we're going to write 2.7, that's where the decimal place is. Then we do multiply, so an x, and this is where the base 10 comes in. You put a 10, and then we have to deal with the exponent. So we move the exponent 1, 2, 3. We moved it 3 places to the left. And when you move the decimal place 3 to the left, it's going to be a positive 3 for the exponent. So it would be 2.7 times 10 to the power of 3. Now let's try one where we have a number less than 1. So what if you have a small number? We have to move the decimal place, but this time we're going to move it to the right, and we're going to stop after we pass the first number that's not a 0. So 1, 2, 3, 4. We've moved it 4 places, and we're stopping just after that first digit, which we can see is the number 4. We're going to put in 4.5. That's where the decimal place would have been moved, multiplied by our base of 10. But this time we're moving the exponent to the right, and we've moved it by 4. So if you move the decimal place by 4, your exponent is going to be negative because it moved towards the right, and we moved it 4 times, so negative 4. So that's how we take some whole numbers or decimals and put them into exponents. Now on your calculator, you might want to take a look and see there's a few different ways you can use scientific notation. Some calculators just have an E or an EE. EXP is good. My favorite is 10 to the power of X button if you're writing something in on scientific notation. This is one that's great to use for a lot of the problems that we're working with. So take a look for that button and see if you can find it. This one you might need to look. Often it's a shift button, which means it's not usually a key button on your calculator. You might have to push second or shift, and you'll see it in a different color on your calculator, maybe in green or yellow or whatever the shift keys are on yours. So take a look at that. All right, so let's move on and let's just try some practice problems. So let's put them all up here on the screen. And I'm going to let you try. So the first set of questions, we're going to try and put two numbers into scientific notation. And let's just see, can you expand some numbers from scientific notation to expanded numbers? So pause the video right now, try it out, and when you're ready to check your answers, press play so you can see what the answer should be. All right, so let's check some of your answers. So if we're going to put these in scientific notation, find the decimal place. 1, 2, 3, 4, 5, 6, and 7. We've moved this to the left by 7 places. So we need to put our number in, 2.37. Eliminate all those zeros, but keep all the other digits. To our base of 10. Because we moved to the left, it's going to be a positive exponent, and we moved 7 times, so our exponent should be 7. Next up, this number over here. We have to go to the right this time, because we have a number less than 1, and we have to go all the way over until we pass that first non-zero digit. So we've moved it 1, 2, 3, and 4. 4 to the left. Here there's no numbers or anything after the 1, so we can just write 1 to the power of 4. Oh, sorry, not 4, it's negative 4. Negative because we moved to the right. Let's do the next two examples and check our answers. So here we're going to expand. So this is a little bit different. This is the number we're starting off with, 5.0. And we have to do the opposite to what's above. So when we see something with a positive exponent here, if we're going to expand it, we have to move oppositely. So to put it in scientific notation, we move to the left. And to go to expand, we're going to move it to the right. But how many times to the right? We're going to move it by whatever number the exponent tells us. So 10, that means we have to move the decimal place by 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's where the decimal place has to go. And guess what? We've got to fill all of those in with zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what our expanded number looks like. A lot easier in scientific notation than this expanded form. Let's look at the answer for B. So here you've got a negative exponent, which means this number has to be less than 1. So when we put in scientific notation, we move to the right when we have a number less than 1, but here we're going to move to the left. How many to the left? That's going to be indicated by the exponent again, so 3. So we're going to move this over 1, 2, 3. Our decimal place has to be moved over here. Now when we write this out, we're going to put a 0 in front, put the decimal place in, and here we moved it 2 places, so we need 2 zeros as placeholders to show the size of the number, and then 2, 0, and 6. So that's our answer for B. So hopefully that gave you a good review of scientific or exponential notation.